Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting up the number theory section for Meet 4, looking at sequences and series. So let's get right into it. So the first big topic of number theory Meet 4 is arithmetic sequences. So an arithmetic sequence is defined as a series of numbers where the difference between each consecutive term is equal. So here we have two examples of arithmetic sequences. The first one is 1, 3, 5, 7, 9, 11, 13, and so on. And the second one is 19, 11, 3, -5, -13, -21, and so on. And the one thing that these two sequences have in common is that they're both arithmetic. So first, let's look at the definition of arithmetic sequences. It's a series of numbers where the difference between each consecutive term is equal. So first, a term is just a number in the sequence. So in this arithmetic sequences, our terms would be 1, 3, 5, 7, 9, 11, 13, and so on. And we can also label terms with numbers based off where they occur in the sequence. So this 1, this would be the first term in the sequence. The 3 would be the second term in the sequence because it comes second. The 5 would be the third term in the sequence, and so on. And the same applies to this sequence. Each of these numbers are terms. 19 is the first term, 11 is the second term, 3 is the third term, and so on. So the thing about arithmetic sequences is that in between consecutive terms, which means terms that are right next to each other, like 3 and 1 here, or 11 and 19, the difference will be equal for every single pair of consecutive terms in that sequence. So let's look at an example. If I find the difference between 3 and 1, the difference between 3 and 1, that's going to be 2, because 3 minus 1 equals 2. Now, if I took the next pair of consecutive terms, which is 5 and 3, and found the difference, 5 minus 3 equals 2. If I found the difference between 7 and 5, that would be 2, and then 9 and 7 would be 2, and I think you see the pattern here. Between every single pair of consecutive terms, it's always going to be 2 in this arithmetic sequence. And that's what actually makes it an arithmetic sequence in the first place. Similarly, in this arithmetic sequence, you take 11 and find the difference between 11 and 19, which is -8, because 11 minus 19 is -8. And the thing about arithmetic sequences is when you're finding the difference between each term, you always have to go this way. You have to take the larger consecutive term and subtract the smaller consecutive term. And sorry, when I mean larger and smaller, I mean the one that comes farther, larger means the one that comes farther into the arithmetic sequence. So 11 comes after 19, so you subtract 19 from 11. If you subtract 11 from 3, that's -8. If you subtract 3 from -5, that's also -8. And so on, and the difference between each of these terms will be -8. And then some terminology we have to know about arithmetic sequences are these 4 variables here. So we need to know what these represent. So first, the letter n, when we're referring to any sequence, represents what number term of the sequence we're describing. So if I was saying n equals 5, then that would be referring to the 5th term in the sequence. Then an, so it's a with n here, this is referring to the value of that term. So if n was 5, that's referring to the 5th term in the sequence. So a5 would be the value of the 5th term in the sequence. D then is the difference between each term. So for this first sequence, it was 2, and the second one, it was -8. And it's really important that you always subtract the more left term from the more right term. And then Sn is the sum of all the numbers up to the nth term, which means if I was looking for S3 of this sequence, then it'd be the sum of the first 3 terms, or 1 plus 3 plus 5, which gives me 9. And we'll deal a little bit more with Sn later, but these are the 3 you immediately need to know for the next slide. So when it comes to arithmetic sequences, you need to be able to find a specific term in that sequence. So if it asks you to find the 100th term, for example, in the sequence, you need to know how to be able to find that. So here's the formula to find the nth term in a sequence. And if you forget what all these different variables mean, then I have these arrows right here to remind you. So a to the n equals a1 plus d times n minus 1. where an is the value of the term being found. So if you want to find the 15th term, then an would be a15, and that would be the value of the 15th term. And then so that's equal to a1, which is just the value of the first term, plus, and then d, which is the difference between each term, times n minus 1. And n is the number term being found. So like I said, if you want to find the value of the 15th term, then n would be 15. All right, so let's put this formula to the test. So here's an example question. Find the 17th term in the following sequence, and then the sequence is 3, -4, -11, and -18. So we need to be able to find everything here in order to calculate this, an. So first, we need to know the value of our first term, or a1. And our first term in this sequence is just 3. So we'll write that up here, a1 equals 3. All right, then plus d, and d is the difference between terms. So we have to find the difference in between each term, and it's going to remain the same in an arithmetic sequence. So let's do -4 minus 3. And if you do -4 minus 3, that ends up being -7. So your difference between each term equals -7. You could also think about it this way, where you go from 3 to -4, so you subtract 7 to get there. And when you go from -4 to -11, you subtract 7 to get there, which is why it's a -7 and not a +7. And then times n minus 1. So n is the number term being found. And it wants us to find the 17th term in this sequence. So in this case, n would be 17. N equals 17. Okay, so now we have all the values we need. We just need to put it into this equation in order to find the answer. So we have a to the n, which is what we're trying to find. And I'm actually going to overwrite this as a to the 7, or a17, which is our 17th term, is equal to a1, which is 3, plus d, which is -7, times n minus 1. N minus 1. And oops, I made a mistake because we know what n is. N is 17. So times 17 minus 1. All right, so now if we calculate this out, a17 equals 3, and then plus -7. Oops, that's a dot, so -7 times 16, because 17 minus 1 is 16. And then you do get a calculator for meet 4. So if you multiply 16 by -7, you end up getting -112. So this equals -112 plus 3. Because remember, we still have this plus 3 here. -7 times 16 is just -112. And then -112 plus 3 is equal to -109. So -109 is going to be the 17th term in this sequence. And now I just quickly want to explain why this formula works. Because this formula is actually relatively simple, and you can adjust it based off what you need to use it for if you understand why this formula works in the first place. So our formula says 8n, or an, equals a1 plus d times n minus 1. So let's figure out what this means. So if you were to try and find the value of the 17th term just without this formula, you would probably do, okay, what's 3 minus 7? That's -4, so that's the second term. What's -4 minus 7? That's -11, so that's the third term, and so on. And eventually, you'd end up subtracting 7 from 3, or whatever you result with, 16 times, because you subtracted once to get to the second term, 2 times to get it, or twice to get to the third term, 3 times to get to the fourth term, and so on. And you see the pattern here. Oops, and I realized I made a mistake here. This is supposed to be n minus 1. So you see the pattern here, where the amount of times that you need to use that difference is going to be 1 less than the amount of terms you're trying to find. So if you try to find the 17th term, you need to subtract 7 16 times. So that's where this n minus 1 in this equation comes from. N minus 1 represents the amount of times you need to subtract or add that difference to the original number. So in this case, 17 minus 1 is 16, because we need to do it 16 times. And then you have to multiply that by d, which is your difference, in order to find what the total value you're subtracting or adding is. So we're subtracting, we're subtracting 7 each time, and we did that 16 times. So if we're going through it manually and trying to subtract it each time, we do that 16 times. So to simplify things up, we just multiply it by 16 here. That got us negative 112. And then that's why we add that to the value of the first term, because that's essentially what you'd be doing without the formula, but this formula just simplifies it a little bit. All right, so now I have a review question going over what we just learned. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 119. So the 21st term in this sequence is equal to 119. So it says, find the 21st term in an arithmetic sequence in which A2 equals 5 and A5 equals 23. So since it's asking us to find the value of a term in the sequence, let's write out our term formula. So that's AN equals A1, or our first term, plus the difference, which is D, multiplied by how many times you're going to have to add or subtract that difference, which is n minus 1. All right, so now let's find the values that fill in the values that we already know in this equation. So we need all of these values on the right-hand side in order to calculate AN, which is actually A21, because we're trying to find the 21st term. So that's equal to the first term. And if you look at the question, it doesn't actually give us the value of the first term. So we're going to have to calculate that, and more on that later. And then plus D, so it doesn't give us the difference in between terms. And you can't actually do 23 minus 5, because then you're subtracting the second term from the fifth term. And you need to find the difference in between consecutive terms. So we don't know D either. And then times n minus 1. And n is 21 because we're finding the value of the 21st term. So all we know is n right now. So we'll do plus D times 21 minus 1, which will immediately just simplify to 20. All right, so we need to figure out a way to find the value of our first term and find the value of our difference. So we know that the second term in this sequence is going to be 5, and the third term is going to be 23. All right, so if we're writing out our sequence, it go like this: A1, then we have 5, which is the value of A2, then we have A3, because we don't know these, remember that. Then we have A4, and then we know the value of our fifth term is A5, is 23. So first, let's try to find the value of the terms in between the second one and the fifth one. And the thing about arithmetic sequences, remember, is that the difference between each term is going to be the same. So we can use this to our advantage in order to find the value of these terms. So first, let's find the difference between the second and the fifth term. So if we do 23 minus 5, that gets us 18. So between the fifth and the second term, there's a difference totaling 18. So we need to find the value of the difference between individual terms. So let's see how many differences there are between the fifth and the second term. So first, there's one difference. You jump from the second to the third term, then another difference where you jump from the third to the fourth term, and then one more difference when you jump from the fourth to the fifth term. And these three differences will be equal. Now we know that they total up to 18 because that's the difference between our fifth and second term. So if you do a little bit of math here and divide 18 by 3 total differences, you get that the difference between each of these terms is going to be 6. So the value of D then is 6. So A21 equals A1 plus 6 times 20. All right, so now that we know that the difference is 6, and I'll just kind of prove it by actually finding the values of A3 and 4 first. So if we added 6 to 5, that gets us the value of A3, which is 11. So our sequence would be A1, 5, 11. Then if we added 6 to 11, that gets us 17. And then we know that the next term is 23. And if you check this out, the difference between each term is in fact 6, and it stays equal. All right, so now we can find the value of our first term. And to do this, we actually have to go the opposite way. If you think about it like this, if you're going to the right, if you're finding the value of a term to the right, then you add 6. But if you're finding the value of a term to the left, or the value of A1 from A2, then you have to subtract 6. Because to get to A2 from A1, you would add 6. So therefore, to go the opposite way, to get to A1 from the value of A2, you subtract 6, because that's the difference. So if you do 5 minus 6, that's equal to -1. All right, so A1 is equal to -1. And if we check that out, we have -1, 5, 11, 17, and 23 as our first 5 numbers in this sequence. That definitely makes sense. So now we can put that into the equation, and I'll write it one more time. A21 equals -1 plus 6 times 20. And then times 20. All right, and now we can evaluate our equation because we know all these values. So A21 is going to be equal to -1 plus 120 because 6 times 20 is 120. And then if you add -1 and 120, that gets you 119. So 119 as our final answer. So next we need to talk about finding the sum of arithmetic sequences. So here's how you find Sn of an arithmetic sequence. And remember, the variable s just represents sum, where n is the number of terms you're trying to find the sum of. So for example, S6 would represent the sum of the first 6 numbers of an arithmetic sequence. So here's your formula below. Sn equals n over 2 times times a1 plus an, where Sn is the sum of the first n terms, then n is the number of terms you're finding the sum of, a1 is your first term, and an is the value of that last term that you're trying to find the sum of. All right, so let's do a practice question with this formula. So this one is find the sum of the first 100 positive integers. So if we wrote this out, it'd be 1, 2, 3, 4, 5, and so on until you get all the way to 99 and then 100. So those are the first 100 positive integers, right? And this is an arithmetic sequence because the difference between each term, if you found the difference between 2 and 1, 3 and 2, 4 and 3, and so on, it's all equal to +1. So essentially, it's just asking us to find the sum of all the numbers from 1 to 100. All right, so let's write out our formula. So Sn, and I should cross this out and write S100 because we're trying to find the sum of the first 100 terms, equals n over 2, which is 100 because n is 100 over 2. And then times A1, which is the first term. So that's just 1 plus an. And an in this case is A100 because it's the 100th term because we're trying to find the sum of the first 100 positive integers. And the 100th term in this sequence is just equal to 100. So if we write 100 here, then now we have our formula complete. So if we evaluate this out, we get S100 equals 50 times 101, because 100 over 2 is 50, 1 plus 100 is 101, and then when we multiply that, 50 times 101 is 5,050. So the sum of the first 100 positive integers is 5,050. All right, so I want to go over actually why this formula works, because there are multiple formulas to find the sum of arithmetic sequences, but in my opinion, this one is by far the most easy to remember because it just makes sense when you learn why this formula works in the first place. So let's take a look at a different arithmetic sequence. Say we wanted to find the sum of the numbers in this arithmetic sequence. 1, 2, 3, 4, 5, 6. So here's our arithmetic sequence. We're trying to find the value or the sum of all these numbers. And if you just added them together in your head or on paper, you would end up with 21. So let's keep that in the back of our mind when we're figuring out why this works. So first, let's look at this part of this formula. So it's telling us to find the value of the first term plus the last term because an always represents the last term you're finding the sum with. So the first term is 1, the second term, or the last term is 6. So if we found the sum of these two terms, that will get us 7. Now let's think about this a different way. So if we're to find the sum of these two terms, we would only get 7. But we have these 4 terms remaining that we also need to find the sum of. So let's find the sum of the second term and second to last term. And if you do that, that also gets you 7. And if you found the sum of the third term and the third to last term, that would also get you 7. And if in a bigger arithmetic sequence, like this one, if you found the sum of the fourth term and the fourth to last term, where in this sequence it'd be 4 and 97, that would get you 101. And remember, that's still equal to the sum of the first and last term, 101 as well. So if you're seeing a pattern here, that's awesome. Because basically what this means is that if you find the sum of the nth term and the nth to last term, so like the fifth term and the fifth to last, or the seventh term and the seventh to last, that will always be equal to the sum of the first and last term in any arithmetic sequence. So that's what this section of this formula is asking you to find. So you can use that to your advantage when you try to find the sum of an arithmetic sequence. So we know that we have we know that when we add 1 and 6, that's 7. And we know that when we find the sum of this arithmetic sequence, it's going to be a multiple of 7 then, because we're adding 7 a bunch of times because we have the sum of the first and last term, the sum of the second and second to last term, and the third and third to last term. So now we just need to figure out how many 7s we have in this arithmetic sequence. And since you're finding the sum of 2 terms every time, then that's always going to be equal to your total amount of terms, or n, over 2. So in this arithmetic sequence, we have 3 7s, right? Because n is 6, and if we divide 6 by 2, that equals 3, because you have 3 pairs of numbers that add to 7. So that's why this formula works. When we multiply 3, which is the total amount of pairs of numbers that add to 7, times 7, which is what they add to, that gets you 21. And this applies to any and every arithmetic sequence. The sum of the first and last term will always be the sum of different pairs of terms in that sequence. And then n over 2 is how many pairs of numbers you have in that sequence total that add to that sum. So when you multiply that out, that gets you the total sum of all the numbers in a sequence. All right, and finally, I have a review question going over finding the sum of arithmetic sequences. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 5,577. So the question says, what is the sum of the first 33 terms of the following sequence? -7, 4, 15, 26, and so on. All right, so since it's asking us to find a sum, we're going to write out our sum formula first, and then see what we need to find. So S, 33, because it's the sum of the first 33 terms, equals n over 2, which is 33 over 2, because n is equal to 33. So 33 over 2, then times our first term plus our last term. So our first term is -7, and then plus our last term. And as you can tell, we don't actually know what the 33rd term of this sequence is yet. So for now, I'm just going to write A33. All right, so this is our sum formula. And if you need it written out again, I'll just write it out above so you can compare it. It's Sn equals n over 2 times A1 plus AN. All right, so since we have all of this information, we can almost find the sum of the first 33 numbers of the sequence immediately. But what we don't have is the value of the 33rd term. So in order to find this, then we need to find this value first. So, and we actually know the formula to find the value of a specific term in a sequence. And so we'll write that formula out now. So that formula is going to be AN, which is the value of your nth term, equals the value of your first term. So A1 plus your difference, which is D, times n minus 1. All right, and now let's substitute numbers into here. So we have A33, and I almost always forget to do that. A33 equals A1, which is -7, plus then D, since we don't know our difference yet, times 33 minus 1. All right, so our difference, which is D, is relatively easy to find because we can find it just from here. So if we subtract -7 from 4, so we do 4 minus -7, and you have to be really careful here to actually subtract this term. So it's not 4 minus 7, it's 4 minus -7, then that gets you 11. And if you want to cross-check it, 15 minus 4 is also 11. So we know that our difference between terms is 11 in this arithmetic sequence. So A33 equals -7 plus, and then 11 times 32, because 33 minus 1 is 32. All right, so now we have to multiply 32 by 11. And remember, you can use a calculator for this because this is 4. So -7 plus, and then 11 times 32 is 352. All right, so A33 is -7 plus 352. And then when we simplify that out, that gets us 345. So the value of our 33rd term is 345 in this arithmetic sequence. So now we can substitute that back into this equation, which I'll write out again. S33 equals 33 over 2, which I'm going to simplify right now. 33 over 2 is 16.5. And then that times -7 plus 345. And yes, sometimes you are going to get decimals or fractions here. You could also write 16.5. You're just going to have to learn how to multiply those. And you're only going to get halves when you're using this formula. So in your calculator, 1/2 is equal to 0.5. So if you divide 33 by 2 and get 16.5, then that's 16.5. And you can just enter that into your calculator like that, and it will evaluate it correctly. So we have S33 equals 16.5, then times -7 plus 345. And when we simplify that, we get 338. And then finally, when we multiply 16.5 and 338, we end up with 5,577. So the sum of the first 33 terms of this arithmetic sequence is 5,577. All right, so just to quickly review what we've learned this lesson. So first we started out by talking about arithmetic sequences, which is a series of numbers where the difference between consecutive terms is equal. So these were some examples of arithmetic sequences, and then these are the terms that we needed to know about arithmetic sequences, where n was represents the number term. So if n was 5, then we'd be talking about the 5th term. An represents the value of that term, so A5 would be the value of the 5th term. D is the difference between each term, and Sn is the sum of the first n numbers of that sequence. Then we talked about finding the value of a term in an arithmetic sequence. So to find the nth term in an arithmetic sequence, the formula is here. And then we labeled what these different values meant, just as a reminder. And then we did this practice question and explained why this formula works, where we found the value of the first term plus how many times you'd have to subtract or add that difference, which is d times n minus 1. All right, so then we did a review question where the 21st term in an arithmetic sequence where A2 is 5 and A5 was 23 was equal to 119. Next, we talked about finding the sum of arithmetic sequences, which is represented by Sn. So our formula was Sn equals n over 2 times times A1 plus An. And then we did a review question where we found the sum of the first 100 positive integers, which is 5,050. And then we explained why this formula works, where n over 2 represents how many pairs of numbers you have, and A1 plus An, which is the sum of the first and last term, represents the sum of any of those pairs of numbers. All right, and then finally we did a review question where the sum of the first 33 terms in this sequence here was equal to 5,577. All right, so that's all for today's lesson. I hope it was helpful, and I'll see you next time.